Hello. Thank you. So we go on with the next talk. Will be the last one for today, and afterwards we go to dinner. So we have Simon and Dinos talking about multicast optimizations for mesh networks.
Okay, thanks for the introduction. Yeah, we are talking about forming mesh mobs, group communication in Batman Advanced. We have the outline. I don't know what you know about multicast, so we are going steps down from the very top. What is multicast? How is multicast handled in mesh networks? What is the theory about it? Then we will explain how we implemented our multicast implementation in Batman Advanced. And lastly, we will introduce our experimental platform where we can have a workshop afterwards. The multicast optimization is a work in progress, so please bear with us. It does not work perfectly, but it works. Yeah, so let's get started. You probably know about these communication schemes, but I will talk about it again. We have Unicast, which does this communication 1 to exactly 1. We have broadcast, which is communication from 1 to all who can listen. And multicast is about communication from 1 to a group. So this is the whole difference. There are more communication schemes like geocast, anycast, but we won't talk about that. In general, most of you probably know Unicast and broadcast. What can you do with multicast? This is a set of applications where it is used mostly for audio and video streaming. So for example, you can broadcast TV or radio content to a group of people who are interested in it. It's used in the industry for monitoring systems, so maybe you have little sensors which measure temperature and other stuff. It's used for conferencing systems, both audio and video. So maybe you have a group of people who want to talk to each other. Most of you probably have it on your laptop with some kind of zero config or MDNS, and maybe you are interested to have your own application. I heard about some French music application built on multicast, which sounds very interesting. So what we really have to do for multicast is form the groups first. Yeah, it's not clear who is in the group and who is not. So the nodes in the network have to announce the membership. This is done by using the Internet Group Management Protocol for IP version 6 or the multicast listener discovery in IP version. Did I say something wrong? Yeah, yes. Okay, you catch me. Okay, ITMP is for IP version 4 and MLD is for IP version 6, and it's on the slide so you can read it correctly. And basically, you can announce I'm part of this group or of multiple groups, or I just leave the group because I'm not interested in this TV station anymore, or something like that. Of course, you have to think about addressing. Where you have addresses, which we will consider is in layer 2 and layer 3, in the MAC layer and in the IP layer. Usually, the source address is always from the sending host. And in Unicast, you just put the destination MAC address or IP address, depending on the layer, in the destination field. In broadcast, you put in special IP address or MAC address in the destination field. For the MAC address, you usually see FFFFFF. And for IP, you use usually the last address on the subnet. So, yeah? Why one left is red? Yeah, because usually you see FFFFF, but only the least significant bit of the first byte actually is for announcing that this is a broadcast frame. And for Multicast. and this is Multicast. This is an example for IP version 4. There are some addresses reserved for IP version 4 Multicast. The same is for IP version 6. Basically, you have a 224 network which you can use for multicast communication, and you have MAC addresses starting with 105E, and you convert the IP address you are using to a MAC address. This is displayed here. So you use the last 23 bits and put it in the MAC address. You use the first 3 bytes with the reserved MAC address, and this remaining bit is always 0. Why I'm talking about this is embedded in advance. You know, it's a layer 2 protocol, so we don't care at all about the IP version 4 or IP version 6. We will only consider the MAC addresses. So if you see any MAC address starting with this, we are having multicast present. So we get the next step, multicast and mesh networks. Mesh networks usually should support some unicast communication, of course. Some also support broadcast. For example, Batman started, and you can always emulate multicast by using broadcast. So anyone can broadcast, and just assuming that everyone who is not interested in it will just drop the packet and don't listen to it. This is pretty simple, not very optimal, but simple. And for example, how we do that, the broadcast in Batman Advanced is called classic flooding. And classic flooding basically repeats a broadcast packet when it receives it the first time. So we need some kind of duplicate checking. And we have an example here. So the little orange node may be the source of the broadcast, and it sends to its neighbors because they can receive it. And both of them will repeat it. So this one will hear it, and all of them will repeat it again and again. So everyone will have it repeated after it's flooded through the network. If we don't have too much packets, of course. And as you can see, these nodes on the left side are not group members. Or I tell you that now, the green one are the group members. So basically they are not interested in this, and it would be enough to just flood it in the right part of the mesh network. But as simple as the scheme is, we just flood it to everyone. There are a lot of algorithms already in evaluation, and there are a lot of papers about different algorithms. And what we have seen is that there are basically 2 approaches which can divide it by for what kind of multicast network it is targeted. So if you have very large groups, like we say group size is more than 50% of the mesh, then we call it a dense network. And in this dense network we don't care about the groups, we just flood it, but we flood it optimized. So this is, for example, what also OLSR uses with the MPR. It selects some multi-point relays, so only these special nodes rebroadcast, but not the others, which are not MPR. So you get down a little bit of the redundancy, because as you have seen before, everyone rebroadcasts, and this is a lot of redundancy. The other type is sparse networks. This is when you have rather small groups, we just say group size less than 50%. And in these cases, it might make sense to build a distribution infrastructure. It means, as pictured here, only the right side is interested in the multicast, and the others are. So we probably build a tree or something else on this part of the mesh network, and only flood it in this part of this mesh network. And And this is also the approach we have taken. Yeah, this is where I pass it to Linus, who will explain the technical details.
Okay, yeah, so I will go on this part with the optimization we did. So basically the classic flooding works well when we have things like zero-config ARI stuff, where we don't have so much traffic, so that works okay. But as soon as you want to do multimedia stuff, it's too much burden for the network. So yeah, as Sam already explained, at the moment, or the previous advanced use classic flooding, and now we wanted also to have an optimization for such sparse networks. Yeah, we've been developing it at Subsnet, and our approach is a proactive one. Okay, louder. Great. Thanks. Okay, so the first step we are doing is to sniff and get a hold of which nodes are actually interested in certain multicast groups. So our approach now is to be multicast group specific and see which nodes in our network are interested in certain groups at all. These information are then attached to OGMs, which are basically our control packets for that. So like what is Arios TC for the main packet type, I think. And we have louder. Yeah, and we have OGMs as our basic control packet type. So OGM stand for originator messages. Yeah. So we just attach the new information about which node is in which group and flood this through the whole network. So every node now knows where are my receivers. Okay. So the next step is with this information we are trying to build up a tree so that we are not flooding it through the whole network anymore, the data packets, but just on the optimized paths which are only needed for it. So therefore we've introduced a new packet type, we call them tracker packets, and they are sent in advance over the paths. So they are sent via Unicast. For instance, here's the sender, we just focus now on this node, and it's sending to all other members of the group such tracker packets. They're sent by Unicast or the normal Unicast packets, the normal Unicast paths, which are calculated before with pattern advance already. So it's just on top of it. And yeah, so then those nodes, the purple, pink ones, they know that they are responsible for a certain group and for this sender to forward the multicast data packets. The other gray ones will never hear these tracker packets. So they will never be forwarded and triggered to actually forward any multicast data packets. One further optimization we did is, maybe you cannot see it so nicely here, but these are dotted lines. So actually, for the last hop, we don't need to send the tracker packets because we're just sending the tracker packet from here to the next one to here, and that's it, because we actually only need to inform the forwarding nodes that they have to forward. The listeners, they already know that they want to receive the packet, so they are not forwarding, so we don't need to send the packet for this last hop. So especially in a very when the receivers are all just one hop away and the neighborhood is quite large, then we don't need to send any tracker packet at all. So
the basic idea is that everyone who hears a tracker packet is a forwarder. So he has to forward whether he's in the group or not. So even the big ones can be assumed that they are not in the group, but they still have to forward the packets. Yeah.
Are you saying that the sender has full membership information?
Yes, he has, because all of the member nodes announced that they are in the group by their OGMs, and the OGMs are flooded through the whole network.
So that's done periodically, not so often, but from time to time.
The idea of skipping the last hop is that a receiver, which is at the very end, does not have to forward it any further because there's no one behind.
How does they all move before the back?
Sorry?
So how did those packets forward packets to send to say to the node that it has to be that it has to forward. Okay.
Forward.
Yeah.
For receiving.
How this is by Unicast send or how they are sent?
Yeah, it's a Unicast send.
So then the sender has to know who is on the bed to each node to send forward them or not.
They just follow the routes built up by Batman from the normal Unicast routing. So it's just on top.
So you send to the end user, to the subscriber, and everybody who gets forward packet from the way to the subscriber remembers that it has to send.
Yeah, it remembers a certain amount of time, let's say 5 or 10 seconds, but okay, I'm a forwarder for this group and this source, and if he gets a data packet, which we will see later, then he will forward.
And what about if packet loss is encountered?
Well, we're sending maybe once a second those record packets.
No, the data packet loss, the data. Because here is one, if one, the first node just doesn't receive, then the whole network doesn't receive the traffic.
Yeah.
So that's always the problem in machine networks.
Yeah, but here it multiplies. So here, if you have one node, how the main network doesn't.
Yeah, it multiplies, just as it multiplies for Unicast packets.
But it should use the
but you get one node before.
We will see later that the multicast data packets are either sent in broadcast mode or in unicast mode. In unicast mode, you are lost if it's lost. And in broadcast, maybe some server might hear it and then they still can forward it. Okay, so this is here so far. Then we can move on with the.
Yeah, and now move on to the data packets. If the infrastructure building is okay, presentable.
Yeah, but other you have several labels here. You said you just do Unicast, but then if you have these that are forwarded, you do Unicast here, and Unicast here.
I mean, if the gray ones are also.
If they are also members, or
You have like some networks here. You have 3 forward next to
yeah,
this one.
when I separately send it to all of the 3
Yeah,
forwards.
so it is 3 times Unicast.
But it's done periodically, you can set it, it's like right now 2 times a second.
The data is also sent. How about data? Data is okay.
So we come to the next one.
Data is on the next one. Maybe we really move on to data now.
One more question.
These things are sent using IP or using MAC address? Like you're saying
MAC address, it's just with our own protocol type because we're on layer 2 within Batman Advanced. So we're just using our own Ethernet type. So Batman already has its own Ethernet type, and we just add a new Batman type.
Okay.
So no IP needed for this.
Yeah, this is no IP. We have Ethernet packets encapsulated in Batman packets, which are then sent over Ethernet, which without IP. It's a pure layer 2 protocol.
Okay. Batman goes to the
On that, that's what we
Okay.
need.
Next slide. So the Multicast data forward. So the pink ones already know that they shall forward the data packet, and here now the green node here can send the data, and we are basically now distinguishing between 2 things, 2 modes that we either send it by Unicast, like all the solid lines, and here of course there we have the advantages of AIQ mechanisms, and we can use higher encoding rates, so it should be more reliable and we should be able to get more throughput on these things. But however, if you have a quite dense neighborhood, like here it has 3 nodes it has to forward to, then or after a certain threshold it might make sense to just send it by a broadcast. And yeah, so we do that after the threshold we send it with a broadcast instead of Unicast.
Yeah, we call it the fan-out limit. So if you have, say, more than 2 neighbors where you have to forward it to, you send it to broadcast.
That's think the WBMv4 plugin also does something similar.
Yeah, we have stolen it from this plugin.
Yeah.
It's a good idea, actually.
Yeah.
At least we think so.
Okay. Yeah, so that's the file for the data forward. If there are not any more questions for the forward.
Can you be closer?
Okay, yeah, I tried. Sorry.
Okay, so, and a question for the back.
Yeah.
So this first one, he sends what he has as a destination address.
He sends multicast data packet.
So that special address is
For his group. Yeah. So you can imagine that there are maybe different groups.
Yeah.
So that there are different trees for different groups, and he does it for his group. And also for each source which is sending, there are different trees. Of course.
Yeah. And because this one is so all those three gets it, this packet, the neighbors, but only the forwarder sends it.
Yeah. Basically, Wi-Fi is broadcast, so maybe others will get it, but only the pink one will forward it.
In Unicast it will be dropped earlier.
Yeah, it will drop in the driver.
Okay. So the next slide. Yeah, so I said before, it builds upon the normal Unicast routing of that in advance. So it's basically the same method for choosing paths. The last node in the tree does not rebroadcast. The leaf nodes don't do this anymore, which was differently with the classic flooding approach, because which was similar with in the classic flooding, the leaf nodes also had to rebroadcast because they had
Really louder.
Even louder, okay. Then I will try. Let's see if that works. Okay, sorry, I'm not used to it so much. So okay, I try.
You talked about classic flooding and
Yes.
nodes.
Okay. Here in the classic flooding, the node always had to rebroadcast it because it had no information of if there are any other nodes which still need this packet. But with this node, the leaf nodes do not have to rebroadcast it. So we are saving some duplicate rebroadcasts. So therefore we have a massive decrease of duplicates, especially when we have a lot of neighbors in the single hop neighborhood. And here, in that case, all these neighbors do not have to rebroadcast if they don't have to forward the data packet. Okay. And of course, it's not group specific, so only where the actual multicast members are, only in these directions we are sending the data packets. Okay, the limitations so far are, it's not designed for big groups, as Simon described before, it's more for sparse networks. So if you have a lot of group members for the same multicast group, it creates quite some overhead, so with these tracker packets. However, if you only have a subset of the nodes are in the same or interested in the packets, then it can be quite an advantage because then the overhead is minimal with these tracker packets. The current implementation does not distinguish between senders and receivers, so anyone who wants to send a packet also has to subscribe as a listener to be able to notice that these two nodes are in the same room somehow. We have some ideas which we wanted to maybe implement this week, but yeah, that will follow.
We are working on that.
Yeah, work in progress too. And the next part is the IGMP MLD snooping is now kind of implemented, but it's not so much tested. We will see how it works later. So because in Batman Advanced, because it's layer 2, you can also bridge some other clients inside. So let's say your mobile phone can connect to the router, but your mobile phone doesn't speak any Batman. Then the Batman node has to notice that your cell phone is interested in multicast traffic. So this can be done with IGP MLD. So we are trying to snoop that and to announce any other devices which are connected in the mesh network that they are interested in. Okay. Here, then we have the experimental platform here. Let's see how it works. You can just connect your laptop or your smartphones or whatever and start VLC, and we want to see if it works to send some audio and video data to multiple receivers. And here.
we have 4 nodes in each corner.
Yeah.
Yeah, actually we only have 2 of them running right now, but it's working.
That's 50%.
Yeah, it's just not so much of an interesting mesh network with 2 nodes, but anyway.
It's free.
Yeah, you use it. Yeah, and we have set up a VLC server on the small pink box over there. It's playing drum and bass tunes from Andrew, and it's also playing a music video. Can you put it on the next slide?
Yeah.
And we are running it for IP version 4 and also IP version 6. It's great because I just disabled it, but we can try it again on the workshop. So I would like to ask anyone who is interested, maybe after the dinner, I don't know how much time we have left.
No, still 30 minutes.
Yeah, we were fast. But maybe there are a lot of questions. Anyway, we will gather in the Batman corner over there, and then you can come and test with us together, discuss the implementation, and yeah, let's see how it works. And I have a live demo. So I'm currently, hopefully, still connected to the 5 gigahertz. 2.4 is really crowded here, and
why?
because there are so many people who brought so many routers, and I try to connect to the RTP stream of the video. I add this for listening, and this is a multicast address I set up, and maybe we will see a video. Yeah, we'll see it. I'm glad.
I think at the moment it's
So, what is happening now? Maybe it's happening.
Now it's happening. We have the big box. It's this one.
It's not pink, it's pink.
No, so I meant pink. Okay. The pink box is sending a stream to the white box over there. No, this is cable. Then we have a wireless mesh Batman advanced link to the box over there at the door. And then my laptop is connected via infrastructure mode to the access point to this box. It announces with the IGMP message, hello, I'm interested in this stream. Then the bridge snooping comes on and it says, oh, okay, I have to forward the stream now. And yeah, when the magic happens, the stream is sent, the RTP packets are sent, Ethernet cable, Batman, infrastructure.
And you're running Batman on the laptop. So this is
no, not on the laptop.
and also not on the stream, so they both have no Batman.
But maybe you explain in a few short words how that works with layer 2, because I don't think everybody knows how a client can be connected without running mesh.
Okay.
Yes.
So here, the difference between layer 2 or layer 3 is we can build a bridge on it, and just a Linux bridge. It behaves like a switch which you might have on the table, and it just forwards Ethernet packets or Ethernet frames from one port to another, and the port might either be Ethernet or might be a Batman interface or might be an access point interface, and this is exactly what happens here. So on this one you have a bridge of at least 2 ports from the access point and from the virtual Batman interface. So the Ethernet packet comes directly over there, then is encapsulated in the Batman packet and sent to the box over there. Where it's decapsulated, given to the bridge, and the bridge is giving it to the Ethernet, and it goes to the big box.
Okay, and this node knows that it has forward data
because it's a switch and it behaves like a switch.
It detects the client.
It detects the client from like a switch does. If you send an Ethernet packet, you see, oh, okay, there's this MAC address, and if the other Ethernet frame comes in with a destination field for the MAC address, then it sends it out on this port.
Okay, but you're saying that this is not multicast.
Yeah. This is Multicast, and I send an IGMP packet, and the bridge has IGMP snooping, so it knows that for this port it has to send the packets, has to relay the packets to this port. And otherwise, if it would not have the IGMP snooping, it would just handle this broadcast and put it out on all of the ports.
Okay.
Yeah, maybe I should have talked a little bit more about the bridging and stuff.
What happened with Ally? Because you know that this is not good with large roads.
What happens in not dense networks? And in dense networks, and not in sparse networks. If every client has Avahi running, I guess that's what. Yeah. What happens then?
Well, in this case, everyone would announce his membership, and then everyone would start sending tracker packets to everyone. So everyone is like n to the 2 times packets per second, or even more. So you will have a lot of management overhead just to find out the optimal trees.
So it would be more than the classical filtering.
Yeah, because you have, or we assume, maybe you will save some for not sending to the last leaf node, or the leaf node does not have further rebroadcast, but you have a lot of management overhead. So
But only for the nodes forwarding package, not for data. Or for data.
no, the data is handled a little bit else.
Yeah.
I don't know if it's more or less.
Yeah.
But,
okay, so only you will have only this, but it's not so much. This package for forwarding.
the tracker packets, you mean?
Yeah, that package.
Yeah, they are not so much, but in the sum of all of them, they are quite a lot.
Every notice.
I'd like to first say that I'm very much impressed, and I'm especially impressed by the fact that you have the courage to do a live demo. It's really very impressive.
Thank you.
There is one thing that worries me a little bit that I probably didn't understand. Could you come back to the slide with the pink dots? With the pink dots? Yeah. So, if I understood you correctly, what you're doing in order to establish the forwarding tree is having the source of the traffic send n different packets.
Yeah, for the tracker packets.
Now, what is usually done in multicast protocols, in particular in the ENRP, is that the destinations are going to send a single IGMP packet and ask to receive the traffic for the multicast.
Yeah.
And the routers in between are going to aggregate them. So the pin router up there is only going to send one packet saying, look, I have some clients who are interested. Because it's none of the business of the second pin router how many of those are. So I'm wondering why you chose to have the end-to-end subscription service rather than having this form of hop-to-hop subscription services aggregation.
Casting also other protocols like MODB, but what we found is that they are building the trees in the wrong direction. So we want to build them from the transmitter to the receiver, and but they build it the other way around.
Why? Why you want this?
Because we might have asymmetric links, for example. Because we may have asymmetric links, right? This is also the path to in one direction may not be the best path for the upper direction, for the reverse direction.
So, and how does it prevent you from aggregating the subscription?
We aggregate this. We don't send 4 Unicast packets, but we aggregate them in one. We did not have.
Yeah, but you have full knowledge in the sender of all the subscribers, rather than knowing only the neighbors behind which you have subscribers.
I think the problem is that this is not small clouds of switches connected by routers, but it's a mesh. So the situation is much more complicated. You don't have this clean chain of routers connecting layer 2 domains that are independent from each other, but lots of overlapping a radio connectivity. So yes, so a transmitter you can try to aggregate, but maybe you will get something really crazy which might be outdated a few minutes later because a link is gone or a link gets worse or another gets better.
Yeah, this is a proactive approach. So this is also why we set it periodically. Because for the application which we have, it is a mobile application, maybe all of the nodes may be mobile. So if they change, they may even forward the incoming packets for a few more seconds, so there might be multiple forwarders for the same tree.
Could you please repeat the sender learning about the set of subscribers?
The sender will learn about the OGM packets because at the OGM packets there's a group information attached.
So it goes first, the receivers send information that they want to receive it, and then it propagates in the other direction, is that correct?
Yeah, the OGMs are flooded through the whole network, and then the trees are built the other way around here.
So let's discuss it offline.
Okay. Okay, any other questions?
No? For me, no, for 2.4 gigahertz.
Your Unicast route out the correct instant interface.
It didn't work well on 2.4 gigahertz.
What else do you like to change? I connect to the access point. And the PHCP links. I start to try to connect to that.
And that it did not work. And maybe you have to add the multicast route.
So it has to go out the correct interface. It's probably going out to your first interface.
Yeah.
Maybe can you enter the whiteboard because we will
Just in case it doesn't work immediately for you, then maybe it's using the wrong interface. So this might say, my wireless LAN interface.
What interface does it usually use?
The first one.
The first one, no matter what the first one is?
Well, the first one at the top.
Okay.
Which, if you're unlucky, you look like
if you only use the wireless interface, it will probably always work. And if you have Ethernet up to first, then it's probably
okay.
But I have one you 2.4 doesn't work.
I know. I have 5 gigahertz.
Okay. Any more questions, comments?
Otherwise, meet us here and all that. Yeah. Otherwise, just meet us here in the bedroom corner. We're open for questions, discussions, and so on. Or if you want to test it,
yeah,
just stop by.
Thank you very much.
Okay. Yeah.